And then going to part B. Part B says find the nature of the turning point of the curve, and the curve is y equals to 1 over 3 x cubed minus plus a half x squared minus 6x. Now, question A and question B are asking for the same things. But for question A, it first asks us for the turning points and then distinguish them. But part B, this is part B please, but part B is asking for the nature of the turning points of the curve. That means for us to get the nature of the turning points, we must know what the turning points are. Therefore, we find the turning points. And for us to get the turning points, we need to get the gradient function of the curve. Therefore, dy dx gives us, we differentiate this function of the curve. Therefore, this gives us x squared plus x minus 6. This is the gradient function of the curve. Okay, it gives us the gradient of the curve at any point on the curve. But we know that at the turning point, the gradient of the curve is 0. In other words, dy dx is 0. But we know that at turning points, at a turning point, at any turning point, dy dx is 0. Therefore, we need to substitute for dy dx as 0, and then we get the values of x for which the gradient is 0. That is the implication. At the turning point, the gradient is 0. So, what are the values of x for which the gradient is 0 at the turning point? So, we substitute here. Therefore, 0 equals to x squared plus x minus 6. If you look here, this one is a quadratic equation, which you can solve by any method. So, let me factorize this quickly. What is the product? The product is negative 6 and the sum is 1. So, what are the factors? Two numbers. If we multiply, we get negative 6. If we add, we get positive 1. I'm saying 3 and negative 2. 3 times negative 2, negative 6. 3 plus negative 2, positive 1. Therefore, 0 equals to x squared. If you don't know how to solve quadratic equations, please go to our S.4 Mathematics playlist. And then plus 3x minus 2x minus 6. Then we factorize. Therefore, 0 equals to x into x plus 3 minus 2 into x plus 3. 0 equals to x minus 2 and x plus 3. Please make sure you know how to solve quadratic equations. Now, from there we say either. I'm not explaining this very deep because that is not the concept here. So either x minus 2 equals to 0, for which case x is 2, or x plus 3 is 0, and for this case x is negative 3. Those are the values of x for which the gradient is 0 at the turning point. Let me use the calculator to confirm our answers. We just go to equation, go to the degree of 2, 1, 3, 1, 1, 1, negative 6. The first x is 2 and another value of x is negative 3. So those are the two values of x at the turning point. What does it tell us? It tells us that since there are two values of x, there are two turning points. There is a turning point when x is 2 and there is a turning point when x is negative 3. But remember, a turning point is a coordinate point. It has x and y. So let us get the corresponding values of y for each case. So when or for x is 2, what is the corresponding value of y? You come back and use the equation of the curve. Okay, the equation of the curve, because that x equals to 2 is a point on the curve. So our y becomes, we have 1 out of 3, x is now 2 cubed plus, I'm substituting here, where I get x I put 2 plus I have x is 2 but squared minus 6 times x. Then we use a calculator or you simplify in the shortest time possible. Let me first simplify here. I will have 2 power 3 is 8. We have 8 out of 3 plus 2 minus 12. 2 squared divided by 2 is 2. 6 times 2 is 12. Therefore, I will say 8 divided by 3 plus 2 minus 12. I'm getting negative 22 out of 3. Let me confirm that. 8 divided by 3 minus, yes, it is negative 22 out of 3. So the turning point as a coordinate point is 2 and negative 22 out of 3. That is one turning point. And then we need to find the other corresponding value of y when x is negative 3. So for x equals to negative 3, what is the value of y? We substitute for x here and we get y. So that we have y equals to 1 out of 3. Our x is now negative 3 cubed plus a half into our x is negative 3 but it's squared minus 6 times x is negative 3. Where we find x here, we put negative 3. Then we simplify. This here gives us negative 3 power 3, negative 27 divided by 3. Here I'm getting negative 9. Negative 3 squared divided by 2, positive. So here I'm getting positive 9 out of 2. If I simplify it, if you simplify this, and then plus 18. Negative 6 times negative 3 is 18. Then we add negative 9 plus 9 divided by 2 plus 18. This is positive, this becomes positive, this is negative, yes. I'm getting 27 out of 2. Then we confirm that negative 9 plus 4.5 plus 18. 27 out of 2. So this is the corresponding value of y. So the turning point is negative 3 and 27 out of 2. So these are the two turning points that we have. But the question was asking us for the nature of the turning point. So what we have done is to find the turning points. Now let us get their nature. For us to get the nature of the turning points, there are two methods. One, we test for the slope before and after the turning point. Or we use the method of second derivative. I am using the method of second derivative. So I'm going to get my second derivative here, which is b squared 1 x squared. Now, where is the first derivative? It is here. The first derivative dy dx is x squared plus x minus 6. Now let us differentiate this again for the second time. So d squared y dx squared becomes 2x plus 1. This is the second derivative. Now we need to test for the 2 points, the first point and the second point. So for the first point, which is 2, negative 22 out of 3, I'll test it there. Second point, which is negative 3 and 27 out of 2, I'll test it here. When you are testing for the turning points, we use the second derivative for both points, for the first point and for the second point. We know that this is x, this is y. Even here, this is x, this is y. So now for this point, we substitute for x as 2 in the second derivative function. So this squared y, the x squared, becomes 2. What is our x? Our x is also 2, because 2x plus 1 equals to, what is 2x? What is 2 times 2 plus 1 is 5. Now, after getting the value of the second derivative, we judge relative to 0. Is it more than 0? Is it equal to 0? Or it is less than 0? Positive 5 is more than 0. And we say that if the second derivative is more than 0, then our point is the minimum turning point. It's a minimum turning point. What does it imply? It implies that this point is minimum turning point. Therefore, the point 2, negative 22 out of 3, is a minimum turning point. After testing for the first point, we go and test for the second point. This is x, this is y. We use the second derivative function instead. So this squared y, the x squared equals to 2. What is x? Our x now in this case is negative 3. Then plus 1. 2 times negative 3 is negative 6. Negative 6 plus 1 is negative 5. That is the value for the second derivative in the second point. Now we judge, is negative 5 more than 0? Is it equal to 0 or it is less than 0? Negative 5 is less than 0. And we say that if the value of the second derivative, b squared y dx squared, is less than 0, if the value of the second derivative is less than 0, we say it is a maximum turning point. Thus, therefore, the point negative 3, 27 out of 2 is a maximum turning point. We must conclude that, okay, it's a maximum turning point. That is the nature that the question asks. Maximum turning point. In some books, in some solutions, they say the minimum turning point is also called the point of minima. The maximum turning point is also called the point of maxima. So this is the solution to example 4.